Ladies and gentlemen, welcome to the Technical Forum of Hydrogen and Fuel Cell Europe at the Hannover Fair 2022. We have a lot of interesting presentations. The next presentation will be about cell voltage monitoring in mobility and electrolysis applications. And the speaker is Business Line Manager eCell Electronics, and the company's name is Smart Testsolutions. I welcome and ask you to welcome him with a great applause, Dr. Markus Schuster.
Okay, hello to everybody. I'm happy that I can speak here today to you. As the subject is already mentioned here, I'm talking about cell voltage monitoring systems. That is a necessary tool for electrochemical systems such as fuel cells, electrolyzers, and so on. I will give you a short introduction of the components of a cell voltage monitoring system. It's not only the CVM, we have additional components in the meantime that we have to look for. Then I will give you some application examples. And finally, if there is enough time, we can look how a development project for such a component can be set up. So first of all, the components of a cell voltage monitoring system is the CVM. This is the electronic component that measures the individual cell voltages. It's situated close to the electrochemical stack. That can be a fuel cell, an electrolyzer, or a redox flow battery. That is possible as well. Close to the CVM will come the cell voltage pickup, CVP. That is the component that helps getting out the voltages of the bipolar plates. These two components are integrated into mechanical parts that can be mounted to the electrochemical stack. And the data and the power supply must be connected to the outer world. Normally the components are situated inside a stack compartment. The key component here in the meantime is the cell voltage pickup. So Smart provides here a large variety of different standard solutions for contacting the bipolar plates. That can be simple pin contacts, a variety of spring contacts, flag contacts. That is strongly required to get the voltages out of the bipolar plates. So our, I would say, native product for these applications is a modular and flexible CVM system that you can see here. You see on the left side the CVM modules. It can be stacked up to 600 cells. Every measurement module has 10 measurement channels. It has a high flexibility for research and development projects, for test stands, and so on. It can be combined with a so-called master module to give more interfaces, higher data rates, and so on. This construction is modular and flexible. We fulfill the high voltage requirements for larger stacks up to 200 kilowatt. We fulfill the automotive temperature range, and the system is CE conformal, that we are allowed to sell it as a measurement component. So this is the basic technology for all subsequent connections and projects. So what you see here is an application for vehicles in small series, I would say. We are not yet in large series. That can be a car, that can be a truck, that can be a bus. And here you already see that it's not only the CVM. So you have the whiteboard is the CVM. Now it's no more a modular structure, it's a single board solution. The cell voltage pickups here are the small connectors here that are in front of the CVM. Everything is covered by mechanical components for fastening it at a stack, giving the length tolerances and so on. And the CVPs go into pinholes within the bipolar plates, and everything is mounted. And here you see the connection cable to the outer world of the stack compartment. So another focus of SMART is military applications such as ships or submarines. Here we have products for years. That was the first serious project in the company history. So since over 15 years we provide such units. Inside this housing there are the standard CVM modules integrated. Here the CVP is external, some meters away at the fuel cell stack. It can be connected to the front panel here. The particularity of this system is that it has a MIL certification. That means special EMC tests, special shock tests, special vibration tests. But inside there are still our standard components. So what we are presenting on the Hannover Fair this year is industrial application. So inside this housing you have also the standard CVM components. This housing has an ATEX, is ATEX conformal as well as all connections. What is new here is now that we apply a software protocol for Modbus, that we can have an easy access to field bus applications and for PLCs. So finally, you have seen now many applications for different fields of interest, vehicles, submarines, test stand, and so on. So every project has its own particularities. So out of this standard product portfolio, we can provide individual solutions that fulfill the demands of the corresponding market. So a development project normally starts with a feasibility study. So we are discussing with the customers a shape model, 3D model of the electrochemical stack, where we can see where is the space to place the components and so on. This normally has a duration of 6 to 8 weeks. Then we have a first concept, and then we go into a first design phase. We call it basic engineering, where we finish the first mechanical components, the CVM, the cell voltage pickups, and we already do here a kind of pre-validation depending on the market. So if that is fulfilled and we have working and functional prototypes, we go into a third project phase. It's called the detail engineering phase, where we look for the design, if there have to do some changes. As well, that means another pre-validation of the component until we got a design freeze, and then we will optimize the full system concerning producibility to make it more economic, to look for large series or small series production phases. We build up the automated test environments for the electronic components, and finally we look for the cost situation that the customer will get his expectations here as well. So at the end we have a project, and it's finished here when we start with a 0 series delivery. Okay, now I'm at the end. I hope I am in time. 10 minutes, fine.
Thanks a lot, Dr. Markus Schneider. If there are any questions from the audience? Right now, there's no question. If you want to visit him in his booth, it's D211, right?
Exactly.
Thanks a lot for your
presentation. Right over there, just at the beginning.
Thanks a lot for your presentation.
Okay, thank you.